Welcome to this Incisor Custom Add-ons and Custom Objects tutorial. Custom add-ons and custom objects are ways to create custom functionality that can be used in the Incisor graphical user interface. For example, a developer can create a custom add-on to define special properties and behaviors that can then be added to objects in the GUI within the construct panel, and those properties can be manipulated and even animated from within the timeline panel. We'll begin this tutorial in a blank new project. The best way to get started with custom add-ons and custom objects in Incisor is by looking at the examples provided in the Incisor template library. You'll see there are options for both custom add-ons and custom objects. These are two different ways to make custom functionality for objects available within the GUI. Custom add-ons are more modular bits of functionality that can be dropped or added on to existing objects, and custom objects serve as a way to define entirely custom objects. In this tutorial, we'll look closely at custom add-ons, but as we'll see, working with custom objects is very similar. Let's start by adding a custom add-on from the template library. Custom add-ons can be created to add custom functionality to specific types of existing objects, and you can see all of the associated options from within the template library menu. To make a custom add-on that can be added to any kind of object, we can choose a custom add-on scene object, since all hierarchy objects inherit from scene object. For now, we'll create a chase cursor example add-on. By selecting this option, Incisor will automatically generate a new code asset file where the functionality for this custom add-on is defined, so we'll need to choose a name for the custom add-on and the associated file. Let's call it Cursor Chaser. Now we can see that our new code asset file has been added, and the Project Updated button has appeared in the upper right-hand corner of the Incisor GUI. It's important to note that if you're using TypeScript, you'll need to recompile the TypeScript at this time to ensure that the new code asset is compiled and registered for the GUI. Now that our Cursor Chaser custom add-on is included in our project, we'll see a Custom Add-ons menu in the Object panel whenever a scene object is selected. This menu will enable us to add the Cursor Chaser functionality to any object we want to have chase the cursor. Watch as we add the Cursor Chaser custom add-on to the sample text included in the new project. We'll have to toggle the inspector mode off within the live view panel to ensure that the target project is getting normal cursor input. You can see that the Cursor Chaser functionality makes the object it's added to follow the cursor. Since we've added the custom add-on in the live view, its effect is only temporary and will be lost when the project is reloaded. To add the chase cursor functionality permanently, we can either add it in code or add it within a construct in the Incisor GUI. To add a custom add-on in code, we can simply declare a new instance, providing the target object as the parameter. Next, we'll cover how to use custom add-ons within a construct. To make this example a little more fun, we can add some assets to our project and create a space game construct. We'll add image assets to our project, including a starry background, player ship, and alien ship. Next, we'll create a new space game construct and add those images, being sure to set the sublayer values of each graphic object so that everything is visible. Next, we'll change the code in the project main.js file to remove the sample text assembly from the project, and instead we'll have the code add our new construct to the main scene using nc.constructdefs.spacegame.add. We'll also add a line to put the main camera into maximize safe zone mode, which will ensure that our construct will always be visible within the window. Upon saving and refreshing the project, we can see our new space game construct in the live view. Now we can make the player ship follow the cursor by adding the Cursor Chaser custom add-on. Save and reload the project to see our work in action. You can see that our ship follows the cursor but appears to be moving backwards. Notice that when we add Cursor Chaser to this graphic object, a new section appears in the object panel. You can see that our Cursor Chaser add-on comes with a couple of properties we can manipulate. One of the cursor chaser properties allows us to change the rotation offset for the item chasing the cursor, so we can use that to adjust the ship's angle accordingly. If we want to make the player ship keep up closely with the cursor, we can crank up the chase speed property to achieve that goal. When we make this adjustment within the space game construct, the newly adjusted property values will also be saved in the construct file. Now let's give our alien ships the ability to chase the player ship, but to ensure that our new game isn't too difficult, we can make the aliens a bit slower. To do so, we can add the Cursor Chaser custom add-on to the alien ship graphic objects and adjust the chase speed and rotation offset properties accordingly. Now let's save and refresh the project to play our new game. To make our game a little more interesting, we might want to make one of the alien ships slower than the other. Now let's look at the code behind the Cursor Chaser custom add-on and see how we might be able to modify it. The code for creating custom add-ons is basically done in two parts: the definition of the class and the run before init section of the code, in which the new custom add-on class is registered with the Incisor GUI. Since the Cursor Chaser example is meant to be functionality that can be added to any scene object, our class extends the CustomAddOns CustomObject class. By extending the CustomAddOns CustomObject class, this entire class will automatically have access to an owner property, which represents the given scene object that owns the instance of this particular custom add-on. In the class constructor, the chase speed and rotation offset properties are defined, and a callback for the fixed update app event is added that will happen during every frame of gameplay. This is where all of the math is done to point and move the owning object towards the cursor. There is also an enable state change callback added, which ensures that the fixed update callback is removed if the owning object is disabled. The fixed update function first ensures that a local reference to the pertinent camera is connected, and then does the calculation for the change to the rotation and position of the owning object. You can see that after the calculation is made, the fixed update sets the rotation of the owning object as well as the position, which is done using a swoop global position call since the calculation is done according to global coordinates. Once the class for the custom add-on is defined, it is registered with the Incisor GUI. This is done within the run before init section below using the nc.registerCustomAddOn function, which takes the class definition as its parameter. Below that, the register custom add-on property function is used to expose the chase speed and rotation offset properties within the GUI, and to make their values savable within a construct and animatable within timelines. As you can see, the register custom add-on property function returns a registered property object that can be further manipulated to adjust things like value validation and the sensitivity of dragging the associated supervisor within the Incisor GUI. Now let's customize this functionality further by creating bounds for our alien enemies. We can start by adding a new horizontal bound property in the Cursor Chaser constructor. Now let's use that property in the fixed update function to limit the X position of any cursor chasing item with a couple of if statements. We will also register the horizontal bound property the same way the other properties are registered below. Now, if we save and go back to our space game construct, we can adjust the horizontal bound values on the alien ships to enable our player ship to have safe zones on either side of the game area. We can also add a transparent box to help mark these bounds with a visual aid. Now, to demonstrate how we can animate registered properties of custom add-ons, we'll add a new timeline to our space game construct and call it Changing Safe Zones. In this new timeline, we can animate the horizontal bound values for the custom add-ons on our alien ships. When we right-click on the alien ship objects in the timeline panel, we can see that the additional options for the Cursor Chaser custom add-on are available. Adding keyframes to expand and contract the horizontal bound value will effectively allow us to change the size of the safe zones from within the timeline. While we're at it, we can animate the scale of the transparent box to match our new changing bounds. We can ensure that this timeline automatically plays by checking the Autoplay when in construct box and by changing it to be the default timeline for the space game construct. Now let's investigate what we've built. Enabling this kind of custom functionality to be editable from within the Incisor GUI can be a powerful tool when it comes to tightening the iterative design loop and creating better ways for designers, artists, and animators to work together with coders. This space game is a great example of how we can use and modify the custom add-on examples provided in Incisor's template library. As you can see, there are many examples and even blank templates for building custom add-ons from scratch. Comprehensive templates are also provided with lots of blank functionality if you want to take the approach of starting with everything and then removing unneeded functionality. You can also access lots of examples of custom objects from within the template library. The primary differences between custom add-ons and custom objects are that with custom add-ons, you define custom functionality to add to objects, and with custom objects, you are defining entirely custom objects. So for custom objects, this means that instead of extending custom add-on classes, you're just extending normal hierarchy objects such as scene objects, graphic objects, and text boxes. Other than those differences, custom objects are built in a similar fashion to custom add-ons, by defining classes and registering those classes and their properties with the GUI. To quickly show an example use of the custom object, let's add the clock example custom object from the template library. We can call it clock. Once the new code asset file has been included in the project, we can right-click on objects in the hierarchy panel or the live view panel, and we'll see the option for adding our new clock custom object. The clock example is straightforward, defining a customized text box that automatically shows the time with a Boolean option for whether or not to show the seconds. Just like with custom add-ons, custom objects and their registered property values are savable when added within a construct. Let's save and reload to try our final product. We now have a game where the player controls their ship and alien ships are in pursuit. And now that we've added a clock, we know our players will never lose track of time. That's it for this Incisor Custom Add-ons and Custom Objects tutorial. You can also see a practical example of custom objects in use in the Incisor slot template, which defines a symbol custom object used by the reels in the slot game. To download the Incisor slot template, visit incisordevcom/downloads. You can stay tuned for an upcoming tutorial covering the Incisor slot template by subscribing to the Incisor YouTube channel. If you have any questions, feel free to ask them on Stack Overflow or on the Incisor subreddit. Enjoy creating with Incisor.